For this problem, a researcher wanted to estimate the average U.S. salesperson salary, and they wanted to do so by creating a 98% confidence interval. So based on their sample of data, let's construct a 98% confidence interval. If we remember, our confidence interval looks at our sample mean, then it adds and subtracts a certain number of standard deviations or standard errors. Again, this represents our standard error or standard deviation. And here we're representing a central percentage. And specifically, we're dealing with a t-distribution with a certain amount of degrees of freedom. Our conditions are the same for a hypothesis test when estimating a mean. Right? So we need to have a random sample, right, which we saw in our previous video. That was good. We needed to have a sample of at least 30, which we do, and our sample size needs to be less than 10% of the population, which it is. Right? There's more than 490 salespeople, so that's also a check. So let's construct our confidence interval. Right? We'll take our sample mean, our starting point, our sample statistic, and then we're going to add and subtract a certain number of standard errors. Our standard error in this case was 9,422 over the square root of our sample size. The only thing we really need to find here after given our sample statistics is how many standard deviations we need to go in each direction. And the only way we can do that is by getting our distribution calculator. If we were to go to our distribution calculator, we have 49 observations, therefore our degrees of freedom is 49 minus 1, which is 48. And that brings about a t-distribution with specifically 48 degrees of freedom. We want to find the central 98%, so we'll select this last option, which is looking for the between area of 0.98. And what this is saying is if we go roughly 2.41 standard deviations in each direction, 2.41 positively and negative 2.41, that is going to contain the central 98% specifically on a t-distribution with 48 degrees of freedom. Right? This is not true for every t-distribution. It's only true for specifically a t-distribution with 48 degrees of freedom. So our t-star value is plus or minus 2.41. Again, it's actually two values. If we were to construct our confidence interval, we would have a margin of error of plus or minus $3,243.86. Again, we'll add and subtract that to our sample statistic, our starting point, and we would end up with the interval of $63,956.14 to $70,443.86. What this is saying is we are 98% confident. Again, we're not 100% confident. We're 98% confident that the average salary, the average U.S. salesperson salary, is captured in the interval. Right? That's what we can say based on our results. And again, our interval is from $63,956.14 to $70,443.86. We're 98% confident that our population mean of U.S. salesperson salary is contained in that interval, is captured in that interval.